Okay, in this video, we're going to talk about angle of elevation and depression within right triangles. Okay, so as a quick review, we want to remember our SOHCAHTOA. SO stands for sine of the angle is opposite over hypotenuse. CA stands for cosine of the angle is adjacent over hypotenuse. And TOA is the tangent of an angle is opposite over adjacent. Okay? And how we label our triangles is we circle the angle. These are all coming from angle A. So circle your angle. Label your hypotenuse first. It's always across from the right angle. The hypotenuse and the adjacent are going to be touching the angle. So that this green side would be your adjacent. And then up here that's not touching the angle, that would be your opposite. Okay? So angle of elevation is when you're looking up to an object. That's the angle of elevation. Elevation means you go up. And it's formed by the observer's line of sight and the horizontal line. So this angle right here, from the guy where he could be looking to where he's actually looking, that angle is your angle of elevation. Okay? These are all going to be word problems, so drawing a diagram is going to help tremendously. And then once we solve, we're going to round to the nearest tenth. Okay, so Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. Casey is 6 feet tall. How far is she standing from the base of the lighthouse? So, if I draw Casey here, okay, don't laugh at my amazing artistic skills. Remember, Casey is 6 feet, and Casey's line of sight goes here, and she's looking up at a lighthouse that is, the lighthouse is 84 feet, okay? The angle of elevation, which is going to be right here, is 58 degrees. And it wants to know how far she's standing, so it wants to know this right here. Now the first kind of trick with this is Casey, we're not using this 84, okay? Because Casey, this line of sight starts 6 feet above. So what we'll have to do is we'll have to take that 84, subtract the 6 feet, and what we'll get is 78 feet. So this up here is going to be 78. That's what we're going to be using. Okay? Now, since we have this triangle labeled, we're going to use our trig functions like we've been doing in the previous videos. So you circle your angle and you label. This right here is going to be your 90 degrees. So that's going to be your hypotenuse. This is your adjacent because it's touching the angle, and the 78 would be your opposite. So we're not using hypotenuse. So again, we go over to SOHCAHTOA. Okay, and we're not using sine, we're not using cosine because they both have the hypotenuse there, so we will be using tangent. Okay, so we're going to have tangent of 58 degrees. Is going to be equal to, remember, tangent is opposite over adjacent, so it's going to be 78 over x. Okay? Make it into a fraction. We cross multiply. So if I cross multiply, I'm going to get 78 is equal to x tangent of 58. And I'm just going to divide by tangent of 58. And this right here is what I'm going to put in my calculator. Now I'm going to use my TI-84 calculator first, and then I'll do the rest in the Desmos Scientific calculator. I'm using the WABA-EMU app. It's for Androids. There is also an app for the Desmos Scientific calculator if you want to download that. I'm working off an Android tablet, so that's why I have this calculator here. So whatever calculator you decide, you have to make sure it's in degree mode. So if you click mode, make sure that it says degree. Okay, so go down, hit enter, and then hit second mode to get out of that screen. All all right? So we're going to do 78 divided by tangent of the angle, which was 58 degrees. And we get our answer of 78 or 48.73. Now it's asking us to round to the nearest tenth, which is 1 decimal place. So we're looking at these numbers. That 3 is going to tell the 7 to stay. So this right here, 48.7, that's going to be our answer. So x is equal to 48.7, and we're talking, it's a word problem, so we're talking about feet. So we're going to be Casey's going to be standing 48.7 feet away from the lighthouse. Okay? So let's do another example. So the angle of elevation from a kicker's foot on the football field to the top of the goal post bars is 17 degrees. If he's standing 131 feet from the base of the goalpost, how tall is the goalpost? Okay, so let's go ahead and draw our picture. So we have a kicker, and he's kicking a ball. So we have a ball here, and he's kicking it. He's 131 feet away from the goalpost. Okay, and he's kicking it at an angle of elevation of 17 degrees. Okay, and it says how tall is the goalpost. So that's what we're using here. We have our 90-degree angle here. So let's go ahead and label this triangle circle. Our hypotenuse is up here. Okay, again, touching the angle, the adjacent is going to be down here, and then the x is going to be the opposite. So again, if we draw out our SOHCAHTOA, we're not using the hypotenuse, so we're not using sine, we're not using cosine. Again, we're going to be using tangent. For these, for some reason, we use tangent a lot. It's a coincidence. It's not an every time we're going to be using tangent thing, okay? So we have the tangent of the 17 degrees. That's going to be equal to, remember, tangent's opposite over adjacent, so x over 131. Now this one's a little bit different because the x is in the numerator versus up here when the x was in the denominator. Okay, so when we cross and multiply, we're going to get x is equal to 131 tangent of 17 degrees. All right, so this right here is what we're going to put in our calculator. I'm going to use the Desmos calculator for this one. So again, make sure if you're using this Desmos that it's in degrees, okay? Because if you don't put it in degrees, it gives you the wrong answer. So 131 tangent of 17, enter, we get 40.05. That 5 is going to round that 0 up to a 1. Let me just show you, I don't think I've showed you yet, what happens if you put it in radians. See how the answers, see this whole thing moved to radians, but see how this answer changes when I put it from degree to radians? Okay, so just make sure that you keep this bad boy in degree, all right? So our answer, what was the answer? 40.1. So the goalpost is going to be 40.1 feet. So that's angle of elevation. Let's now look at angle of depression. Okay. Actually, I want to do number 4 really quickly. Because it's different than the other two that we've done. So let's just go ahead and look here. So we have a dog that's standing 5 feet away from a tree. So we have a dog here, and it's standing, we have a tree here, okay, and it's standing 5 feet away. All right, looking up at a cat that is 16 feet above the tree. All right, so here's our triangle that we have here. It wants to know what is the angle of elevation the dog. So it's asking us for x here. So in this case, we're looking for the angle, which is a little bit different than the last time. So again, we circle the angle. The 16 is going to be the opposite. The 15 is going to be the adjacent because it's touching. And then we don't have any information for the opposite. So if we write our SOHCAHTOA, again, we're not using sine or cosine, we're using tangent here. So we have tangent of the angle is going to be equal to opposite, which is 16, over adjacent, which is 5. Okay, now this one's different because we're looking for the angle this time. So we're actually going to have x is equal to, we're going to use those inverse functions. So tangent -1 of 16 divided by 5. And again, if you're using the TI-84 calculator, you're going to be using the second tangent. Make sure it has that -1 right there, okay? So second tangent of 16 divided by 5. Make sure it's also in degree mode. We hit enter and we get 72.64. That 4 is going to tell the 6 to stay. So we have 72.6 degrees. If we use our scientific calculator in the Desmos calculator, remember we're going to go over to function and hit tangent -1 and then 16 divided by 5. Again, we're going to get the same answer, but we get 72.6. So whatever calculator you're using, just make sure you're using that second inverse. So again, the angle of elevation is going to be 72.6 degrees. Okay? So now let's talk about the angle of depression. So the angle of depression is when you're looking down at an object. So it's actually outside. See how up here it's outside of the it's outside of this the right triangle. All right, but because this is creating that Z pattern, those Z angles, we have alternate interior angles. So what does that mean? That means that this angle is going to be congruent to this angle, okay? So the angle of depression is going to be congruent to the angle of elevation because they're alternate interior angles, which in my class I call them those Z angles. They're the insides of that Z, okay? So angle of depression is where people start making mistakes, and I'll show you what I mean by that. So we have a lifeguard. He's sitting at a platform. And he's looking down at a swimmer, okay? So he's looking down at a swimmer. We have a swimmer, and we're having this right angle. But remember, the angle, if the lifeguard looks straight ahead, he would be looking out this way. So if the lifeguard's line of sight is 8 feet above ground, so that means his platform is 8 feet above ground, and the angle of depression is 18 degrees. Now, this is where people mess up, okay? Because what they do is they put the angle of depression right inside of the right triangle. That is not where it goes. Whoops. Okay? Where it actually goes is it goes on the outside of the angle. So here is where the 18 would go. But just like we just talked about, we have these Z angles, so that means this angle and this angle are going to be congruent. So that means that this angle down here is going to be 18 degrees. Okay? And then it's asking how far away is the swimmer from the lifeguard, so our X would be down here. All right, so circle your angle, label your triangle, we have the hypotenuse, opposite, adjacent. So we're not using the hypotenuse. So again, if we look at our SOHCAHTOA, we're not using sine, we're not using cosine, we're going to be using tangent here. Like I told you, tangent is just a coincidence that we keep using tangent here, but it's okay. So we have tangent of 18 is going to be equal to opposite over adjacent. So 8 over x, okay? Cross multiply, we get x tangent of 18 is equal to 8. Divide by tangent of 18. And this right here, 8 divided by tangent of 18 is what we're putting in our calculator. So let's go ahead and do that. So let's clear this. What are we doing? We're doing 8 divided by tangent of 18. And we get 24.62. Again, we're rounding to the nearest tenth. So the 2 is going to tell the 6 to stay. So our answer, how far is the swimmer from the lifeguard? He's going to be 24.6 feet away from the lifeguard. Okay. We're going to do 2 more. So a pilot in a helicopter spots a landing pad below. If the angle of depression is 73 degrees, the horizontal distance to the pad is 1,200 feet. What is the altitude of the helicopter? Okay, so again, we have the helicopter up here. It's looking at the landing pad down here, okay? The horizontal distance is 1,200 feet. It wants to know the altitude. Altitude is the height. It's a fancy way of saying height, okay? And we have an angle of depression. Remember, the angle of depression is going to be out here, but whatever's here is also going to be here, so it's going to be inside here as well. All right, so that is what our triangle is going to look like. We have the hypotenuse, opposite, and adjacent. So again, if we use our SOHCAHTOA, we're not using hypotenuse because there's no information there. So we're using tangent. We have tangent of 73 is going to be x over 1,200. Cross multiply. Okay, so we get x is going to be equal to 1,200 tangent of 73. We go ahead and put this in our calculator. Let's go do that. So we get 1,200 tangent of 73. We get 3,925.02. The 2 is going to tell the 0 to stay. So our answer for how far away is it, or how high is it in the air, is going to be 3,925 feet. Okay. Okay, I'm going to do one more. Because this one seems to be a little bit confusing, but that's okay. So we have building A. Whoops. We have building A, and it's 480 feet tall. And then we have building B, which is 654 feet tall. So let's go ahead and just draw that. So we have A, and then we have B. And A is 480 feet, and B is 654 feet. Okay, so if the angle of depression from the top of angle B to the building is 42 degrees, how far apart are the buildings? So we want to know this right here. That's what we're trying to find. And this would probably be easier if I drew this a little bit more accurately. It's going to be taller. So this right here is what's actually going on. Okay, so we have an angle of depression. So remember, the angle of depression is 42. So 42 is going to go down here. All right. Most of the time, guys, your angles is going to be down by the bottom of your triangle, if you haven't noticed that. Please, usually it's not going to be up here. All right. So the problem is we don't have like a height for right here. We do though. What we're going to do is we're going to take these two numbers and we're going to subtract them. We're going to take 654, we're going to subtract 480. Okay, when we do that, we get 174. So 174, that's going to be our height. So when we label our triangle from here, okay, we have the hypotenuse, the opposite, and the adjacent. So again, we're not using hypotenuse. We are going to be using tangent of 42. Tangent is going to be opposite over adjacent. Remember, tangent is TOA. Okay, opposite over adjacent. So 174. Lord. Over x, cross multiply. Get 174 is equal to x tangent of 42. And I get x is equal to, I'm going to go ahead and put this in my calculator. So that's going to be 174 divided by tangent of 42. And I get 193.24. That 4 is going to tell the 2 to stay because it's under 5. So my answer is going to be 193.2 feet apart. So that's what that distance between the two buildings would be.